Hello and welcome to our video tutorial. In this lesson, we will be looking at Unit 5, Lesson 4, Reflections in the Coordinate Plane. We will be reflecting our coordinate points about different lines. Sometimes that line will be the x-axis, like you see here. Sometimes that line will be the y-axis, like you see here. Or sometimes it'll be other random lines. For instance, the line of y equals x, which is a diagonal that goes up this way, or the line y equals negative x, which goes down this line here, or possibly some other random line. We're going to be reflecting those points in different ways. Other skills we will have to use occasionally might be Pythagorean theorem to find the length of a slanted line. So we'll get to and review Pythagorean theorem to make that useful when we need it. All right, so let's begin. So you got point A is this point right here, okay? And it has the point 8, 2. So if I wanted to, we're gonna do question number 1, and then we're gonna use question number 1 as kind of a basis of kind of a shortcut for some of the remaining questions. So if I am to reflect about the x-axis, okay, that means here's the x-axis. I'm going to highlight in yellow. To reflect about the x-axis means I need to take it here and move it down here. So the way to do that, you can see that it's 2 units above the x-axis. Well, I need to flip it down 2 units below the x-axis. That would put it right here. And I'm going to call that new point A prime. Now notice it still has the same x coordinate, but it has a -2 y coordinate. And so I would call this A prime a -2. Okay, now what if I reflected about the y-axis? Well, okay, so the y-axis, I'm going to do this in blue now. The y-axis is right here. And if I reflect this point, to reflect means to make a mirror image right on the other side. So you can notice that A is 8 units away from the y-axis. Well, that means I have to put A prime 8 units on the left of the y-axis, right here to be exact. So there's our A prime reflected about the blue y-axis. And the coordinate points for that would be -8, 2. Notice you're on the negative side, but you still have the same positive y value. Okay, let's take a look at one of the shortcuts that's already developed. If I am reflecting about the x-axis, then the x stays the same, and I change the sign of the y. If I reflect about the y-axis, well, the y stays the same, and I change the sign of the x. Okay, so remember from our lesson a little bit earlier that the line of y equals x looked like a diagonal line straight through the origin. So let's go ahead and draw that. I'm going to draw that right here. There's the line y equals x. Okay, now the point A is right here, and it is this far away. Point A is this far away from that line. So I need to put the reflection of A, which is A prime, this far away from that line. Now, how do I find out what that point is? It's very simple. That point right there, in fact, is just the reflection of these points, meaning change the signs. Instead of instead of 8, it's going to be 2. We're going to flip-flop the x and the y. So the x is now going to be 2. The y is now going to be 8. So if I'm flipping about the y equals x diagonal line, then my a prime is just going to be flipping my x and y coordinates. In this case, I get 2, 8. All right, so how about if I need a reflection about the line y equals negative x? Well, y equals negative x is the negative diagonal that goes to the origin. It's this line here. And you can see point A is right here. I'm going to do this in I guess, green. You can see that this point is this far away from that line. Well, I need to go this far away from that line, down over here. Okay, and the way to go about doing that that's going to give me a reflection point right there. Now, how do I do that? Well, what I'm going to do is I'm going to flip my x and y. So I take the x and y and I flip them just like I did here. But notice it's going to be in the other quadrant. So I'm going to also change the signs. So it's going to be not just 2, 8. It's going to be -2, -8. -2, -8. All right, how about the line x equals 4? Well, the line x equals 4, what I'm going to do is I'm going to find x equals 4. So this is 1, 2, 3, 4. The line x equals 4 would be a line that goes straight up and down just like this, right at 4. And you can see that our line, I'm going to do this in gray, our point A is 4 units away from that line, x equals 4. So I need to put A prime 4 units on the right. That puts it right there on the y-axis, right there. A prime would be, what, 0, 2? Okay, and then finally, we're going to plot about the line y equals -1. So y equals -1 is right there. It's a horizontal line right through -1. And what you'll notice about that, I'm going to do this in red, you'll notice that point A is 3 units away from that line. So I need to draw and put A prime 3 units away down here, which would still be 8, but now it's going to be, what, 8, -4? Okay, so we're going to use these properties and principles that we found, these reflections, in different examples as we go through the rest of this assignment here. Okay, so number 2, which single transformation would have had the same effect as rotating the point 3, -3, 4? So let's find it, -3, 4. So the point is right there. By 180 degrees. So by 180 degrees means to essentially rotate it in a half circle. Kind of puts it over here. Well, that's going to put it right at that point there. Then what I would do, and because you can see that we are this far away from here, we're going to be this far away from here. So yeah, rotating it by 180 degrees means rotating it in a half circle, kind of in that direction there, and then reflecting it about the y-axis. So the y-axis is right here, so you can see that it's 3 units away here. So that would put A prime right there if this is A. So what would be the same as rotating that point by 180 degrees and then reflecting it about the y-axis? Well, if you notice, that point is 4 units away from the x-axis, 4 units away from the x-axis, so reflecting about the x-axis would have done the exact same thing. Number 3. In the diagram, parallelogram ABCD, that's down here, has been reflected across a line to produce A prime, B prime, C prime, D prime. Across which of the following lines was it reflected? Now, here's kind of the easy way to figure it out. Figure out the distance between the two. Well, the distance between the two is 6. So if I go halfway, that would be right here. This line appears to be the line that it was reflected about. Because you'll notice that every time for every point, that distance is the same as that distance. That distance is the same as that distance. And for every distance, that would always be true. So what is this line? That's the line y equals 2. Okay, scroll on to number 4. It says the point AB is reflected across the line y equals x and then across the x-axis. Which of the following would be the coordinate points? Okay, so let's get 2 reflections here. So we're going to take the point, and I'm going to kind of use sort of a numerical example just to sort of get the point, and then we're going to apply it to just random points AB. Okay, so my numerical example is, what if, as an example, I use the point 3, 5. Okay, there's my A. And let's say I reflect it about the line y equals x. Well, if I do that, okay, and I get the point, what do I do? What do I do? I need to take those and I need to reverse them. So I get 5, 3. So far we have the point AB. So that's point A. It's point A. It's coordinate point AB. So now if I reflect it about the line y equals x, I need to reorder those. So this would be BA instead of AB. Then I need to flip it across the x-axis. Now when I flip it across the x-axis, remember x stays the same and y changes. So if I reflect it about the x-axis, x stays the same and y changes. So this becomes 5, -3, right? So if I reflect this about the x-axis, I would get B -A. And that would be our new point. Number 5. The grid at the right has a segment AB with endpoints A, -7, 3, and B, 5, 8. Draw the image of AB and line segment AB and line segment A prime, B prime after a reflection in the line y equals x. State the coordinates of that. So first of all, let's draw the line y equals x. Remember, that's a line that goes right up the middle, just like that. There's y equals x. Okay, now what I'm going to do is I'm going to get this line here, this point here is this far away from the line. So that means B is going to be right here. B prime is going to be right there. Okay, same distance away. This one here, that distance right there. So I'm going to copy that, the exact same distance on the other side. And that puts A prime down here. There's line segment A prime, B prime. Okay, now what are those coordinates? Well, remember, if I flip about the line y equals x, all I got to do is flip the coordinates. So the coordinates would be as follows. So the coordinates for A are -7, 3. So the coordinates for A prime would be 3, -7. I just flip the x and y. The coordinates for B are 5, 8. So the coordinates for B prime would be 8, 5. Part B, use length AB and length of A prime B prime and the distance formula to find the lengths. Well, you can use distance formula or you could use Pythagorean theorem. Remember, Pythagorean theorem says A squared plus B squared equals C squared. So just to kind of remind you how that works, let's say you had a triangle that had a side of 3 and a side of 4. How do you find the side of this hypotenuse here? We're going to call that side C. So if this is A and this is B, and A squared plus B squared equals C squared, that means 3 squared plus 4 squared equals C squared. That means 9 plus 16 equals C squared. Well, 9 plus 15 is 25. And the opposite, what number squared would give you 25? Well, C would be 5. Okay, or the square root of 25. You could do it that way too. So we're going to just use Pythagorean theorem and we'll be able to figure it out pretty easily. Okay, so I'm going to use different colors here. I'm going to use red. So this is going to have, we'll go 1, 2, 3, 4, 5. So one length is 5. The other length is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 5 and 12. And I got to figure out the length of AB using that. So I'm going to go 5 squared plus 12 squared equals C squared. C is going to give me the length of AB. 5 squared is 25 plus 144 equals C squared. Add those together, I get 169 equals C squared. And if I take the square root of both sides, C equals 13. And that's the length of line segment AB. Okay, now we do the same thing with A prime, B prime. I'll do this in green. So I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and over 1, 2, 3, 4, 5. So if you think about it, we're doing the exact same thing, but opposite. So instead of up 5 over 12, it's over 12 and up 5, which basically means what? 12 squared plus 5 squared equals C squared. We have 144 plus 25 equals C squared. Still have 169 equals C squared. Square root both sides. C still equals 13. So A prime, B prime, the length of that segment, right, is going to equal 13. Okay, so it should make sense. If it's a reflection, those two lengths ought to be the same. All right, so now and that's what part C is all about. Explain why the lengths you found must be equal. Reflections are rigid motions and rigid motions preserve or keep distance or length. It should be a mirror image, right? Mirror images are going to have the same distance and length. Okay, think about it this way. If you were standing in front of a bathroom mirror, the height of you is going to be the same height as the reflection you cast in the mirror. Same idea. All right, moving on to our final problem, number 6. On the grid, we have triangle MNP. Is plotted with the vertices M, that's 10, negative 2, or sorry, negative 10, negative 2. N, which is negative 6, negative 6, negative 9. And P, which is 1, negative 5. Okay, the line y equals negative 3, 2/3 x is also drawn. Okay, that's this line right here. Draw the image of triangle MNP after a reflection in of this line. Okay, so what we're going to do is we're going to take each of those coordinates and we're going to flip it about that line. So M prime is going to go over here, right there, about right there. P prime is going to go about right there, and N prime is going to go about right there. Okay, so first of all, let's list the things. So give the coordinates. So M, so if M has the coordinate negative 10, 2, that means M prime, we're gonna flip. M prime is gonna be negative 2, but positive 10. So M prime is gonna be negative 2, but positive 10 all the way up here. And you can see that distance right there. So that distance right there is the same as that distance right there. So that would be M prime. Okay, N is going to be what? Negative 6, negative 9. And so N prime would be, so it's down here. That's going to end up all the way up here on the other side. That's just going to be 6, 9, just opposite sign. So 6, 9, that puts it right here. That's N prime. And you can see this distance here, right, is the same as that distance there to make it a reflection. All right, and then finally, point P is 1, negative 5. And so looking at where point P is, that same distance would be, looks like 5, 1. Perhaps maybe 5, 2. 5, 2. That point will be the same as that point. No, not 5, 2. That would be 5, 1. 5, 1, not 5, 2. Sorry about that. Yeah, that distance right there of 5, 1, that would be the same distance as that right there. There we go. Okay, so that would be our P prime. So this, oopsie, which I'll do in a different color, is going to be our new triangle, M prime, N prime, P prime. So explain why triangle M prime, N prime, P prime must have the same area. Well, if the lengths are the same, then area of triangle is 1/2 base times height. So if the lengths are the same, then the areas must also be the same. That concludes our lesson here. I hope you found it to be helpful. Please remember to go back, pause, rewind it at your speed. Thank you, and see you next time.